Hello everyone. This is Dr. R. Sasikumar, Professor, Computer Science and Engineering Department from RMDEC Engineering College. Today we are going to discuss about IPv4 classful address. IP version 4. IP is nothing but what? Internet protocol. V for version, the version 4 address. So the address structure is, it can be divided into two structure. One is a network address, another one is a host address. So the network address denoted with 1 and the host address denoted with 0. So we will see the detailed explanation of IPv4. So the notation, there are three common notations available in IPv, Internet Protocol Version Address. The first one is a binary notation, the base is 2, and the second one is a dotted decimal notation, the base is 256, and the last one is a hexadecimal notation, the base is 16. In binary notation, the Internet Protocol Version Address is displayed as a 32-bit. So to make this address more readable, one or more spaces are usually inserted between each octet. Each octet is nothing but what? 8-bit. So in the right-hand side, the yellow shading denoted as a binary number. So we have a 32-bit. So every 8 bits, one space will be provided. So totally 32-bit. This is the binary notation. The another notation is what? A dotted decimal notation. So the user wants to read and more compact and easy to read. It is usually written in decimal form with a decimal dot separating the byte. Okay. So instead of 8 bits, we can represent it into a decimal number. So 8 bits called 1 byte. So 31 will be represented in terms of 8 bits. Again, the another space, instead of space, here we have to mention that dot symbol. And the third format is what? Hexadecimal notation. So the bottom one is what? A hexadecimal notation. So here the each hexadecimal digit is equivalent to 4 bits. So one F is nothing but what? F can be represented into 4-bit binary number, and one also can be represented into another 4-bit binary number. So every 8-bit binary number can be represented in terms of hexadecimal. I already told in the previous videos, the hexadecimal is start with A to F. Instead of 10, A can be represented 11, B, 12, C, 13, D, 14, E, and 15, F. So the decimal number start with 0 to 9, the binary number 0 and 1 only. So the IPv4 address, it is also called what? A hierarchical address. A 32-bit IPv4 address is also called a hierarchical address, but divided into two parts. The first part is called what? A prefix. The prefix always define the network part, and the second part is always called what? Suffix. The suffix define the node. So on the right hand side, we have one structure format. Within the 32-bit, we have a two classification or two partition. The left hand side, the blue color yellow shading is called what? A prefix, and the right hand side is what? A suffix. The prefix defines that network. The suffix defines that number of nodes available in that network. So the prefix length is n bit. The suffix length is what? 32 minus n bit. A prefix can be fixed length or variable length. The network identifier in the IPv4 was first designed as a fixed length prefix. This scheme is referred to as a classful address. The new scheme also available in that recently, that is called what? A variable length network prefix. It is also known as what? A classless address. But in this video, we are going to see about classful address. So in classful address, totally the whole address space was divided into 5 classes. The starting name is called Class A, Class B, Class C, Class D, and Class E. In that fixed length prefix, everything will be represented in terms of 2-power combination. So n equal to 8, n equal to 16, and n equal to 24. So each of these classes has a valid range of IP address. Among 5 classes, the Class B and the Class E are reserved for multicast and experimental purpose. IPv4 is divided into 2 parts. One is a network ID, another one is a host ID. So I already told that in the previous slide. Right. So the prefix defines what? Network. The suffix defines what? Host ID. The host belongs to what? In that particular network. So number of hosts available in that given network. So in IPv4 address, the address space is divided into 2 major parts. One is a network ID, another one is a host ID. So now we will see that classful address elaborately. So we have totally 5 classes already I mentioned, class A, class B, class C, class D, and class E. So we will see one by one. So the class A, the format of the class A is what, totally 32-bit. Among 32-bit, the first MSB bit 0. So the higher order bit of the first octet in class A is always set to 0. And the remaining 7 bits in the first octet are used to determine the network ID. So here the structure of that classful address is what, network ID and host ID. So here the 7 bits called what, totally 8 bits. The 8 bits will be assigned for network ID of class A. Remaining 24 bits will be assigned for host ID of class A. Okay, what is the purpose of that higher order bit 0 means what? That 0 is always denoted as a class A, starting with the class A. The remaining 7 bits what, determine the network ID. So 2 power 7. So 2 power 7 is nothing but what, 128. In that 128, the first address and the last address will be assigned for reserved purpose. So that therefore the class A has a total of 2 power 7 minus 2. What is the purpose of subtract 2 means what? That 2 address will be assigned for special address. That meaning is called 0.0.0.0. This is dotted decimal notation. And the last address is what, 127.x dot y dot z. So that you subtract 2 address, remaining 126 address will be assigned for network ID. And what about the host means what? The remaining 24 bit will be assigned for host. So you have to mention in terms of 2 power combination. So 2 power 24 again minus 2. The first address and last address will be assigned for special address. So the total host is what, 16,000. Sorry, 16,777,214. That much of host is available in network 126. So each network which contains somewhat 16 millions. Okay, this is most probably we are using the topmost MNC company. They are using that class A address. Okay, this is the way to identify that whether the address belongs to class A or class B or class C. So in that class A, for understanding purpose, I repeat once again, the class A, the network ID is 8 bits long, and the host ID is 24 bits long. So in 8 bit, the first bit 0 denotes as class A. So remaining 7 bit, so 2 power 7, 128, 128, the first address and last address will be for special address. So remaining 126 will be assigned for purely for class A network. Each network which contains what, 16,777,214 host ID. Okay, so this is the IP address. So the IP address of the class A is ranges starting from 1.x.x.x to 126.x.x.x. The meaning is what, 1.0.0.0 to 1.0.0.126. Then again 1.0.1.0. Likewise, it will increment. So the huge amount of address space is available in IP addresses are available in class A. So the last one is example 110.34.56.45. This IP address belongs to class A because this is comes under what, 1 to 126. So 0 to 127, that is what, class A. If it address started with 128 means what, that will be that is not a class A address, that is belong to some other class. So we will see one by one. So this is the class A notation. I hope you understand this class A. The next we move on to class B. So the class B, again we have a 2 format. One is a network ID, another one is a host ID. So here the total class strength is what, that's a 32-bit. Among 32-bit, the first 16 bits will be allocated for network ID. Another 16 bits will be allocated for host ID. In that network ID, the first 2 bits are 10. That 10 which denoted as a class B address. So remaining 14 bit will be assigned for network ID. I told already, right? So how many networks available means what? 2 power 14. So 16,384 network addresses available. Each network which contains how many number of hosts means what? 2 power 16. So 2 power 16 again minus 2, 65,534 host address. So every network which contains what, 65,534 host address. So the IP address starting range is what, 128.0.x.x to 191.255.x.x. So meaning is what? Here the first 128 assigned for class A, that is a difference. Okay, 0 to 127, the difference is what? 128. Okay, the first address and the last address will be special address. So remaining 126 will be assigned for class A. Here the class B total difference is what? 64. So the class A ended with 127. So the class B started with 128. Then in the it will be end with 191. So the another the class A, the difference is 128. Now it will be divided by 2. There is a class B is what? 64. So the starting range is 128, ending range is 191. This is the example. So 132.128.56.45, that is an IP address of class B. So I repeat once again, the range of class A is what? 0 to 127, that is the difference 128. The range of class B is what? 128 to 191, the difference is 64. Then we move on to class C. The class C, again we have a two format, one is a network ID, another one is a host ID. Among 32 bit, the first 24 bits will be allocated for network ID. The remaining 8 bits will be allocated for host ID. Okay. And in that network ID, the first, the higher order 3 bits are 110. These 110 represented as always the class C address. The remaining 21 bits are used to determine the network ID. So how many number of networks available in that class C means what? You have to 2 power 21. So 2 power 21, the 20,97,152 network addresses available. Then how many hosts available means what? Here the network address is more. Each network which contains what? 2 power 8 minus 2. The minus 2 is assigned for special address and 254 host address. So every network which contains what? 254 host address. What is the application of class C means what? That academic organization, they are using that class C address. So the IP addresses belongs to class C ranges. The class B ended with 191. So class A obviously started with 192, end with 223. The class A different is 128. The class B different is 64. So the class C different is 32. This is the example 212.208.63.23. So this is within the range 192 to 223. So this address belongs to class C. I hope you understand that class C. And the class D, the class D is used for multicasting purpose, not for commercial, right? This is 32 bit. Among 32 bit, the first 4 bits, 1110 denoted as a class D, and remaining 28 bits called host. So the class C up to class A, class C, class A, class B, and class C is used for commercial purpose. The class D is not for commercial one. This is experimental purpose. So that's the multicasting. Okay, the starting range is what? Class D starting address is what? The class C is ended with 223. So obviously the class D started with 224 up to 239. Because I repeat once again, the class A different is 128, class B different is 64, class C different is 32. Obviously, the class D difference is 16. So this is the example of class D 225.224.63.23. The 225 belongs to class D. So this is what this class D is not used for commercial purpose. This is for reserved purpose, reserved for multicasting. Okay. So here no network, only host. And we move on to class E. The class E, that is the last address. And this is purely reserved for experimental and research purpose. Here within the 32 bit again, which is similar to host, class D also. But the first 4 bits, 1111 denoted as a class E. Remaining 28 bits allocated for host. So 2 power 28, that much of a host is available. And the class does not have any subnet mask. So the higher order bits for first octet class E is always 1111. The IP address of class E ranges is what? The class D is ended with 239. So class E started with 240, maximum 255. So 242 to 255. This is also difference 16. Okay. So the IP address is what? Started with 0, ended with 255. So 0 to 127, this is the summary I have mentioned in that right hand side. The class A is what? Starting address is 0.0.0.0. End address is 127.255.255.255. Most of the MNC company, they have used that class A. And class B, that is a middle organization, they have used class B address. The starting address is 128.0.0.0, ended with 191.255.255.255. Then the class C educational organization, they are using the class C. The address is started with 192.0.0.0 and ended with 223.255.255.255. The class D reserved purpose, so starting address is 224.0.0.0, ended with 239.255.255.255. And class C is for research purpose. This is also not used for commercial oriented. The starting address is 240.0.0.0, ended with 255.255.255.255. I hope you understand that the class will address A, B, C, D, and E. Thank you.